All right, guys, we're going to look at some matrices, doing inverses of them, and some matrix equations, solving matrix equation using inverse matrices. It's good stuff. All right, first of all, we need to know what the identity matrix is. The identity matrix is a square matrix where every entry in the main diagonal is 1 and everything else is 0. Down here, the pictures, that's a 2 by 2 identity. See, it's got 1s in this diagonal, 0s everywhere else. There's a 3 by 3 identity known as I3. 1s in the main diagonal, 0s everywhere else. There's a 4 by 4 known as I4, and 1s in the main diagonal, 0s everywhere else. So that's what the identity looks like. All right, and what the identity does is this. When you multiply an identity matrix times another matrix, you get the same thing. So it's it's kind of like multiplying by 1. 1 times 5 is 5. So if you multiply a matrix times an identity, you get the same matrix. Here's a 2 by 2 example. Here's a 3 by 3 example. And I hope you remember how to multiply matrices. If not, we'll review that in class a little bit tomorrow. Good little skill, though. All right, the inverse of a matrix. Two matrices are inverses, and this is what this is basically saying. Got to be a square again. But the inverse, known as this, the little -1 exponent, is when you can multiply two matrices and you get the identity. If you multiply two matrices and you get the identity matrix, that means they are inverses of each other. You say that the inverse of A is the inverse of A. Okay, so one more time. If you take two matrices and multiply them together and you get the identity matrix, which is the ones with the 1s and 0s in it, those two matrices are inverses of each other. Okay, so what they're going to do in their assignment tomorrow is they're going to say, okay, prove that these two are inverses. So matrix A is 2, 1, 5, 3. And matrix B is 3, -1, -5, 2. So if you forgot how to multiply matrices, watch this slide really closely. So you'll kind of know what we're doing. First of all, this is a 2 by 2. That's a 2 by 2. Because the two middle numbers are the same, that means we are allowed to multiply. That has to be true for you to multiply. The outside numbers tell you what kind of matrix you're going to get. We're going to get a 2 by 2. So we're going to get a number, a number, a number, and a number. That's what it's going to look like when we get done, a 2 by 2. And the way you multiply is you do a row times a column. Like this blank right here is in the first row in the first column. So I'm going to multiply this row times that column. So I'm going to go 2 times 3, which is 6, and 1 times -5 is -5, and you always add them together. Okay, now I'm going to do this one. I'm going to do this row and this column, because that's what this is. This is the first row, second column. So I'm going first row, second column. So I'm going to do 2 times 3, and, sorry, just messed that one up. Sorry about that. 2 times -1, which is -2, and 1 times 2, which is 2, and you always add. Okay, so what I just did, I just went across, down to get these two numbers. I went across, down to get these two numbers. Now I got to get this one. That's in the second row and the first column. So I'm going to do the second row of this one times the first column of that one. All right, so I'm going to go 5 times 3 and 3 times -5. That's -15. I'm going to add those together in a second. And the last thing I'm going to do is this row times this column. This row times this column. And that's going to give me 5 times -1 and 3 times 2. Going to add those together. Now watch what happens when I add these numbers together. Something very magical could happen. 6 plus -5 is 1, -2 and 2, 15 and -15, -5 and 6. Look what I got. I got the identity. So that means these two matrices up here are definitely inverses of each other. Okay, the next thing I'm going to have you do is find the inverse. Okay, if it's a 2 by 2, there's a great shortcut. And that shortcut goes like this. You do what's called the determinant. You multiply this direction, you multiply this direction, and you subtract. That gives you 2. This is a lot of steps. Stay with me here. It's quick, but it's a lot of steps. That number right there is called the determinant. You're going to take that number, you're going to flip it, and you're going to put it in the front of the matrix. This is where it gets crazy. You're going to take the first number here and the fourth number there, and you're just going to switch places with them. You're going to take the other two numbers, the 5 and the 2, and change the signs on those two. And that's really it, except for we're going to distribute that 1/2. So I'm going to make it 3 halves, -5 halves, -1, and 2. Now, what that is this right here, this matrix we just found, is the inverse of that one. And if we multiply those two, we will get the identity. Okay, so again, real quick shortcut. Multiply diagonal, subtract. Once you get that number, take the reciprocal of it, put it in the front. Then just switch places with the third and fourth numbers, Change the signs on the second and third numbers. Quick shortcut. Okay, you can also do 3x3s, and I'm just going to say we need to save that for class tomorrow because the video would be very, very long if I showed you a 3x3 there. So we'll get good at that tomorrow, but it's quite a process. Okay, so just trust me there. Put it this way, you need to be there tomorrow because it's quite a process. Okay, last thing here. Solve the system using inverse matrices. Okay, to do that, we're going to set up what's called a matrix equation. And the matrix equation is going to look like one matrix is going to have the coefficients in it, like that. The next matrix is going to have the variables in it. And the third matrix is going to have the constants, or some people say the answers in it. All right, so let's move that up. Now, our job is to get the x and y by itself like we always do. So I've got to move this one over. Okay, now, right now it says this matrix times that matrix. And by the way, that's a 2x2. That's a 2x1. It's legal because those are both 2's. And you're going to get 2x1 for an answer, which is exactly what that is. Okay, now, there's no such thing as matrix division. And think about what division really is. Dividing is really multiplying by the reciprocal. Okay, now, the real word for reciprocal is multiplicative inverse. Did you catch that? Multiplicative inverse. Okay, so what I'm going to do is I'm going to find the inverse of this 2x2, and I'm basically going to multiply both sides by that, and that lets me move it over. So let's go through the steps again. Multiply this way, multiply the 5 and -3, always subtract. That's going to be 3. Okay, so what's going to happen, I'm going to flip that, which is going to be 1/3. Let me put the xy here. It's going to be 1/3. You take the first and the fourth number and you switch places. You take the other two numbers and you change the sign. All right, just like that. Now, I didn't show this, but I really multiplied both sides by the inverse. Remember what you get when you multiply inverses together. You get the identity. And if I do the identity times the xy, you still get xy. So no need to show that. That's just what you get when you multiply inverses. Okay, to finish up, got to figure out what this xy equals. Always save the 1/3, the fraction in the front, till the end. Don't distribute it yet, even though we did a few minutes ago. When you're working an equation, I want you to wait. Okay, now don't forget how we do this. We're going to multiply this row times that column, this row times that column. So I'm going to do -6 times 15, which is -90. I'm going to do 5 times 36, which is 180, and that's going to give me 90 right there. Now I'm going to do the second row times the column. I'm going to get -3 times 15, which is -45, and 2 times 36, which is 72. And if I add those two, I'm pretty sure that's going to be 27. All right, now luckily, 3 goes into both of those numbers. 3 goes into 90 30 times, and 3 goes into 27 9 times. So my answer should be 30 and 9. And you can plug that back into the top. I'm doing that right now in my head, and it does work. So that's all you got to do. That's solving using inverse matrices. Probably looks a little bit daunting just on the video. You actually did a little bit of this in Algebra 2. It shouldn't be brand new to you. And as always, we'll perfect it tomorrow, right? Can't wait to see you.